Okay. Good afternoon, everyone. All right. So starting off, if I checked a little while ago to see of who has sent me their performance tasks. Okay, so I have most everyone. There's still a couple of people that I haven't got it yet from, and a couple of people, and I've talked to one or two of those specifically. But if you still need to get me your performance task, please do that as soon as you can, and email me if you have any specific questions or issues, and we'll try to sort that out. But otherwise, we're going to go ahead and go on to our next section, or next unit, I guess, which is sequences and series. And so sequences and series is something that we'll definitely use in calculus. Okay, it becomes a big part of one of our last units in calculus, is doing a lot of stuff with sequences and series. So let's take a look at that. Just the basics, though, of what a sequence even is. So you've talked about some of this stuff a little bit in geometry. A little bit. Very tiny bit. I don't know if you remember talking about arithmetic sequences or geometric sequences in geometry. But you did. And we're going to talk about those again. Not today, but we'll get there. Let's just first build up a couple properties of what a sequence is and kind of some different things with that. Okay. All right. So starting off, definition. A sequence is a discrete function whose domain is a subset of the whole numbers. Often the domain is the natural numbers. Okay, so natural numbers, I don't know if we've specifically talked about what the natural numbers are, but the natural numbers is just the like the positive, so the positive integers, if that means anything, which just means like the typically referred to as the counting numbers, right? It's kind of a informal way of saying it, but what that means is like 1 2 3 4 5 6 7 8. Okay. So just like if you were to start counting something, that's what the natural numbers are. 1 2 3 4 5 6 7 8. No fractions, no decimals, no zero, no negatives. Right. Notation, usually we represent the nth term of a sequence by a sub n, or an. Graphically, we treat n as the x-coordinate and a as the y-coordinate. So that's kind of why we have this part. N we can think of as like the input, the domain, so like the x value. And then f, what we get out of that is like what we can consider our y value. Okay, so for example, I have this sequence an, and it's defined by n squared plus 1. So what this means is if I wanted to figure out, a sequence is basically just looks like a list of numbers, right? It's not very exciting at first, but so like if I want to know what's the first number, well, then I look at a1, so I plug in 1. Well, 1 squared plus 1 is 2. All right, if I want to know the second number in the sequence, so a2 represents the second number in the sequence, so I plug in 2. 2 squared is 4. 4 plus 1 is 5. Or a3. 3 squared is 9. 9 plus 1 is 10. Right? Or a4. 4 squared is 16. 16 plus 1, 17. Right? Etc. And we could just keep doing that forever. Right? So if I actually listed the sequence, it would look like this: 2, 5, 10, 17, and etc. It would just continue on. Right? So if, in its most boring way to think about it, a sequence is just a list of numbers. Right now, that those numbers are made by some specific relationship or equation or formula, whatever you want to call it. But at its heart, a sequence is just a list of numbers. All right, so a couple more sequences. So find the first 5 terms. I don't know if I'll do all 5 for all of them, but at least give you the idea. So AN. So this is the equation that defines the sequence. So the first term, I just plug in 1. Negative 1 to the first power is just negative 1, so 2 minus 1 is 1. To find the second term, I plug in 2. Negative 1 squared is positive 1, so 2 plus 1 is 3. Or A3. So I plug in 3. Negative 1 cubed, so that would still just be negative 1 because it's an odd exponent. So 2 minus 1, we're back to 1. A4. Negative 1 to the 4th power, that would be an even exponent, so the negative would disappear. So 2 plus 1, 3. I think you can kind of see the pattern here of this sequence is just alternating back and forth between 1 and 3, 1 and 3, 1 and 3, 1 and 3, forever. Right? It's super exciting. I love this sequence. Oh my gosh. Crazy. I feel crazy. I said that. Okay, so for this one over here, 2n over n plus 1. So first term, numerator would be 2. Denominator, 1 plus 1 is also 2. So my first term is 1. Second term, so numerator, 2 times 2 is 4. Denominator, 2 plus 1 is 3. 4/3. It's kind of ugly. A3, numerator 2 times 3 is 6. Denominator 3 plus 1 is 4. 6/4, which I can simplify. As always, we always want to simplify if we can. To 3/2. Right, and you get the idea again. So if I listed this out, 1, 4/3, 3/2, etc. If I wanted to know the 4th term, I would plug in 4. If I wanted to know the 9th term, I would plug in 9. If I wanted to know the 147th term, then I would plug in 147. Okay, so the nice thing about just kind of these simple, straightforward sequences is we could figure out any term that we want. All right, it doesn't matter who it is, or it doesn't matter what specific term we're looking for. All it matters is we know where we want to look, and we can just immediately find that because we have some sort of formula or equation to build that. Good question. Smart Notebook hates me. It won't let me write. You might just want to try restarting. Smart Notebook actually hates most people, including myself. So, I don't know. Might want to, if you've already closed it and started Smart Notebook over again, you might just want to restart your whole computer. Like actually restart it, not just close it and open it. That sucks, but it might be your best bet. Okay. A couple more. I don't know that I need to. This is why you print them or make them a PDF. It's a good point, Finley. Finley's got this on lockdown. But again, let's say first term, so I plug in 1. 1 squared over 2 to the first plus 1. 1/3, etc. This one's very interesting though, because so if I plug in 1, I would just get 2. If I plug in 2, so 1 plus 1/2, that would be 3/2 squared. So 9/4. which is 2.25. If I plug in a3, or if I want to find the third term, a3, 1 plus 1/3, so that's 4/3 cubed. 64/27, which is, let's see the decimal here, 2.370. Right, and if I continue here, so fourth, 1 plus. Okay, I'd get about 2.441. And the interesting thing about this particular sequence, so we've actually talked about this before in our class, 1 over 1 plus n to the nth power. This is the expression that gives us Euler's number. So actually, as n gets bigger and bigger and bigger, as n goes to infinity, this is approaching e. All right, the number e, which is, I forget, 2.71 something. (2.71828). E, my favorite number. What a great number. Right, so again, this is an expression that we'll definitely see pop up a lot in calculus as well. And so we'll have to actually know. So commit this to your brain that 1 over 1 plus, or sorry, 1 over 1, or 1 plus 1 over n, all to the nth power, as n goes to infinity, as n gets larger and larger, that gives us e. All right, we're definitely going to use that a lot. Okay, so next up, a recursive sequence. A sequence that is defined in terms of preceding terms of the sequence. In order for this to work, we have to already know some of the first terms. So what does this actually mean? So let's find the next 5 terms. So here is my formula. If I want to know, so k plus 1 represents the next term compared to ak, right, which just represents the term before. Right, since that little number refers not only to what do we plug into the formula, but it also refers to which term is this. So a1 is the first term, or a2 is the second term, or a3 is the third term. So if we say, well, ak plus 1, that just represents the term that comes after the kth term. Okay, so if I want to know a2, right, so ak represents the term that comes before a2. Well, that's a1. So k, 1 plus 1 over 2, a1. Okay, notice k and k here. K and k. 1 plus 1 is 2. 2 over 2 is 1. So 1 times a1, and we already know that a1 is 3. So the second term is also 3. All right, so now let's figure out a3. So that means if a3 is the next term, then the term that comes before that is a2. So k is 2. So in the numerator, 2 plus 1, all divided by 2. Right, again, this number comes from just whatever the placement, I guess you could say, of the term that comes before it is. So a2 is the second term. So we plug in 2. So So that's 3 halves times a2, and a2 we know is 3. So 9 halves. A4. So the term that comes before it is a3. So in the numerator, 3 plus 1, all divided by 2. Again, 3 plus 1, 4. 4 over 2 is 2. So 2 times a3. Oops, well, I can just say, we already know a3 is 9 halves. So 2 times 9 halves. That would just equal 9. Those 2's would cancel. Sorry if you guys can hear. There's a lot of construction going on like outside my window. So if you can hear a lot of like beeping and stuff like that, that's the good old construction crew. Sorry about that if so. Probably shouldn't be able to hear it too much, but I can definitely hear it. So all right, a5, so the term before it would be a4. 4 plus 1 over 2. So 5 halves times a4, which is 9. So 45 halves. Oh, so you can hear it? Sorry. Let me go close. All right. I closed all the doors between me and the construction that I could. Tell them you're teaching and you're more important. True. I mean, they're probably watching my stream right now just because they love learning math and they heard about how popular my stream is. All right, so these are the first 5 terms. So it goes 3, 3, 9 halves, 9, 45 halves, and then it would continue on. Your mom always tells you that she's teaching and that she's more important. Is that what you're saying? Our students are more important. Ouch. Did you try using a bug and a wish whenever she says that? All I wanted was a pretzel from Quick Trip. Dude, that's all I want too. Holy crap. Those pretzels from Quick Trip, that's the real deal. Are they still doing those though? I haven't been to Quick Trip since this has happened. I thought that they closed down all their like bakery stuff and whatnot. Oh, snap, really? Okay, this is a game changer. I didn't even know that. Because I got a Quick Trip super close to me, so. Actually, this stream's canceled. I gotta go to Quick Trip. So, again, write the next 5 terms of the sequence. Drop off a pretzel for me. We'll see, but you'll have to soak it in bleach for 2 days before you eat it, just to make sure it's clean. Okay, so actually we're given the first term and the second term. Now we need that because the formula is based off of n minus 1. So n minus 1 represents the term before. N minus 2 represents if I go 2 spots back, so the term before this term. Right? No one will drive me. That's harsh. Even if they have the opportunity to get a pretzel, if my sister, even if I like, oh no, even if I was so pissed off at my sister, if she came into my room and was like, "Hey, will you drive, will you drive me to Quick Trip? I know you hate me, but I'll give you a pretzel." Like, I'd be like, "All right, I'm in. Game on." Now, the story doesn't make sense for a lot of her reasons because my sister's older than me, so there's no reason that she couldn't drive. And I don't hate my sister, but didn't stop. Harsh. Okay, so we know A1 and A2, so let's figure out A3. So A3 is the term that comes before A3, so that's A2, plus the term that comes before that, which would be A1. And both of these terms are just 1, so 1 plus 1 is 2. A4 is the term before, which would be A3, plus the term 2 terms before that, A2. 3, oops, not 3. So A3 is 2, plus A2 is 1, so 3. A5 would be these two terms added together, right? The term before and the term before that, so that's 5. A6 would be these two terms added together, so 8. A7 would be these two terms added together, so 13. All right, so this sequence actually turns out to be 1, 1 was the first two we were given, and then 2, 3, 5, 8. Do you know the name of the sequence? So this is actually a very famous sequence. I don't know if you've heard of it or not. I bet you've heard of it, maybe if you don't even recognize it. Geometric sequence. No, it's a good guess. Geometric sequence is another like famous type of sequence. It's a very special type of sequence, which we'll talk about. This one has a name. I don't know if you know. I don't know how much cryptic reading you guys do, or if you've watched what's the name of that movie or read the book, The Da Vinci Code, right? This is called the Fibonacci sequence, which is related to the golden spiral. All right, so I don't know if any of those things ring a bell to you, but it's called the Fibonacci sequence, which is related to the golden spiral, the Abundus sequence. I fully believe we should rename it to the Abundus sequence. I have no problems with that, but tell you what, Megan, if you can get this officially changed from the Fibonacci sequence to the Abundus sequence, I'll bring you 5 pretzels. 5, the big fiver. That's biased. I don't think that's biased at all. That's an objective reasoning, right? Graphing. So we talked a little bit about graphing, how we can graph this. So let's say my first term, 2 minus 1 over 1, which is 1. So the number that I plug in is like my x value, and the number that I get out of it is like my y value. Okay, so this would represent a point 1, 1. So about right here. I have a mentor session with the president later, so I'll bring it up. Like you are mentoring the president, or the president is mentoring you. These are very different. Right? Yes. Did you say yes to 2 minus 1 half is 3 halves, or 1.5. So this would represent the point 2. Oops. Oh, you are mentoring the president. I see. You're You're doing a heck of a job there. So there's 2 3/2. A3 would be 2 minus 1/3. So 5/3. Right, about 1.6. So not too much higher. We'll go one more. A4, 2 minus 1/4. So that'd be 7/4. Should be about 1.75. Good, he needs it. Okay, so we can see that the sequence kind of starts tapering off and starts getting really, really flat the more numbers that I plug in. Okay, but so we can treat these like x values and y values as well. Whatever I plug in is an x value, whatever I get out is a y value. You teach him Twitter is a tool, not a toy. Well, Twitter, I guess now is an official mode of communication for the White House. Matt's always here, 24/7. He never closes the stream. Right? He has it on at night when he goes to sleep, just in case I open up the 2 a.m. stream. You never know. How did you know that? You know, I can see anyone can look at the chat here and see who's in there, who all the users are. You know, Megan, I would say I'm surprised, but I'm pretty sure you already told us how much you used to fall asleep to Dave Ramsey. Those were the days, the Dave Ramsey days. They were so much fun. I miss going to bed at 9 p.m. Do you not go to bed at 9 p.m. anymore? This is the time that you can now go to sleep whenever you want, because it's not like there's anything in the morning that you have to go to. Right? You know, or it's not like there's anything at night really it's keeping you up. It's fine. 4 a.m. for Finley here, making bold moves. Summer I went to bed at 9. Dad made so much fun when he told me he had no friends. During quarantine, go to bed at like 11:30. Wow. And I guess that's probably true in general, that most people are staying up later now that you don't have to wake up to go to school, like Finley. 4 a.m. That's harsh. That is harsh. All right, so let's talk about factorial. I believe you've talked about factorial in geometry. What this means, when you see this exclamation point, it tells us you take that number, whatever it is, and you multiply it by the number that's 1 less than that, and multiply it by the number that's 2 less than that, and 3 less, and so on, all the way down to 1. Okay, so for example, 4 factorial equals 4 times 3 times 2 times 1. Which is 24. or say 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, you just multiply it by every single number that's one lower than that. You have a factorial button on your calculator as well. Let me pull that up for you so you can see what it looks like. So if you turn it on, first of all, and if you click math, also hold on, let's say we want to do 7 factorial. So I'll click 7, math, and I want to go over here to the probability tab. So I'm going to scroll to the right, and you can see right there, number 4 is the exclamation point. So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, 5,040. Right, so if you ever need to do a factorial calculation, you can use your calculator for it. Right, a couple interesting notes. 1 factorial is 1. Okay, that should make decent amount of sense. I guess let me just move this over. Move it down. 1 factorial is 1. But the really messed up thing is that 0 factorial. I'm slowly becoming nocturnal. The streams are the only thing keeping me on track. That's not good, man. The best thing you guys can do is just try to keep as normal a schedule as possible. Now, whatever normal means, you know, that I don't mean wake up at 6 a.m. every day, but try to wake up at the same time every day. Try to go to bed at the same time every day. Even if that's early, late, whatever. Because otherwise, if you're going to sleep and waking up at weird times and taking naps throughout the day, then your body has no idea when it's supposed to be asleep or what it's supposed to be doing. Right? So you won't be in the right, like literally won't be in the right mindset. Like if you're trying to do schoolwork and your body's like, I don't know, I think I'm supposed to be tired right now. I think it might be bedtime. I don't know. Right? So keep yourself on a rhythm, at least a general rhythm, right? Like, okay, I'm always going to go to sleep sometime between 11 and 1, let's say. Now, I don't recommend that, but if you're someone who's staying up way too late, then, you know, try to set that goal, like, you know, sometime before 1, sometime before midnight. And then try to wake up around the same time every day as 2. Right? And that'll help, because otherwise your body's going to freak out. Yesterday, my mom realized I'll be in the house from April to August, maybe later, and now she wants to explode. That makes sense as well. All right, 0 factorial, also 1, interestingly enough. Right? Kind of crazy, but I assure you, 0 factorial is 1. What a world that we live in. Why, though? It's a good question. So, if you remember, I don't know if you remember from geometry what you use factorial for, but it's used to like tell how many different ways are there to order something. Right? So let's say if I have the numbers like 6, 5, and 7. And I wanted to know all the possibilities for how many different ways could I rearrange these numbers. So like, you know, I could instead do 5, 6, 7 or 5, 7, 6, you know, etc. And if I want to know how many ways can I do that, well, it turns out yeah, permutations and combinations, exactly. How many ways are there? Well, there's 3 factorial. So there's 6 ways. 3 because there's 3 spots. There's 3 elements, right? There's 3 things that we're rearranging. But if I had like 2, 1, 4, 7, 3, and I wanted to know how many ways, well, 1, 2, 3, 4, 5. So there's 5 factorial ways. Factorial button, math, probability 4. Right, so you go to math. Well, you enter in the number that you want, like 8, math, scroll over to probability, and then 4. So there's 5 factorial ways that I could rearrange this these blue numbers. Okay, so let's extend that then to what we were just talking about. So for 1 factorial, right, if I just have one thing, how many different ways can I arrange this? Well, there's only one thing, so 1 factorial, there's only one way. This 3 can only be in this spot because there's only one thing. Okay, but now, so here's where it kind of gets tricky. If I have nothing, right, I have no things that I want to order. How may, nope, try that again. How many ways can you order nothing? Well, how many elements are there? There's 0, so 0 factorial. How many ways can you order that? 1. Because that one way is that you can't. You can't order something. So that counts as one way that you can order a group of nothing things. So that's the explanation for why 0 factorial is equal to 1. Now there's other reasons that you would have to know some higher level mathematics, but do you make your bed only for your streams? No. I'm more consistent about it because of my streams. I would say in general, like BC, you know, in the old world before Corona, I made it like relatively consistently, but definitely not every day. But, you know, I want to put on a good, a nice environment for you guys to learn math in, so it gives me a good reason to make my bed. Plus, I have time in the morning. I'm not rushing. All right, so that's factorial. Simplifying a sequence with a factorial. Often you will expand the larger factorial until you see the small factorial. If the expressions are in a fraction, you then should be able to cancel out common factors, which often is the smaller factorial. Okay, so let's actually see this in practice, and this will be our last thing, I'm pretty sure. Yeah. Okay, 15 factorial divided by 12 factorial. So let's think about what 15 factorial actually represents. It represents 15 times 14 times 13 times 12 times 11 times 10 times etc. Right? The denominator here, 12 factorial, so 12 factorial means 12 times 11 times 10 times 9 times 8 times 7, etc. Well, if I look, all of this stuff will end up being the same thing, right? This is just 12 times 11 times 10 for both the numerator and denominator. So that will all cancel, just leaving me with 15 times 14 times 13, which Megan knows off the top of her head is 2,730. That's right. Told you she did. We can also do that a little more abstractly. So like with this problem on the right, n plus 1 factorial divided by n minus 1 factorial. This will definitely be something we do as well in calculus. So, but let's think about it in the same way. So n plus 1 factorial means I would take n plus 1 and multiply it by whatever number is 1 less than that. So 1 less than n plus 1 is n. 1 less than that would be n minus 1. 1 less than that would be n minus 2, right, etc. N minus 1 factorial, so that's n minus 1, times 1 less than that, which would be n minus 2, times 1 less than that, which would be n minus 3, etc. So again, as I look here, I have some same stuff in the numerator and denominator that will cancel, so that this actually just becomes n plus 1 times n, or n squared plus n. Right? Either way, depends on what we're doing in our problem. If we need to have it factored or if we'd like to have it multiplied out, it just depends.